you will learn today, and you will also learn why Java is actually not so bad for IoT, is how to take your Raspberry Pi or virtually any Java enabled platform and turn it into like a real IoT gateway and build your own IoT solution on top of that. And you will learn about technologies like Py4j, MQTT, COAP, Kura. Some of the technology we will talk about is actually open source technology and Eclipse open source technology. What you won't see today is a live demo. I didn't bring any gadgets, but still I have gadgets in my home that hopefully we will control from here, and thanks to some of the technology I will talk about. So why Java and why not Lua or Python or Node.js? Well, the thing is that Java has been around for about 20 years. There are different sources, but like 9 or 10 million of Java developers, depending on the sources. You have Java 8 that is running very well on embedded devices, including ARM. You have a JVM that runs very well on the ARM CPUs. Just for the record, ARM has shipped 10 billion CPUs/cores in its entire life, and 1 billion in 2013 only. So that's how big the ARM is in the CPU industry, and obviously they have a large slice of the IoT pie. So you can kind of do the math. And Java has also comes with great tooling. You have lots of IDEs, including Eclipse, of course, but IntelliJ and NetBeans, etc., which make it easy to develop your Java application, debug the application, debug it including remotely. Like if you are developing for an embedded device, you will need to have some support for that, right? So that's kind of the, I'm not here to pitch Java, I'm just here to remind you that it's actually quite a good platform for IoT. And what is Eclipse IoT? Eclipse IoT, so basically we have our website on iot.eclipse.org. This is where you will see and learn more than what you will learn today in just 30 minutes. This is a community of open source projects for IoT. As I said earlier during the panel, we have what we call the building blocks for IoT, and many of the projects that we have a dozen projects. Many of them are actually using implemented in Java, and they allow you to connect your device, to manage IoT gateways, to implement server side brokers and stuff like that. So this is what we will talk about today. So very quickly, I'm not here to say once again what is the typical IoT architecture, but still just to remind you that you will always have at some point actuators and sensors. You will have a gateway providing connectivity to your actuators and sensors. Sometimes, well, nowadays it's pretty much all the time, you will have some kind of server-side infrastructure, a cloud to act as a broker, to consolidate the data, to do the device management and stuff. But if you think about what I said earlier during the panel, we are also building the web of things now. So more and more we're going to see solutions where actually there's no cloud at all. We just have actuators, sensors, a way to connect these sensors to the internet, and a user front end, like a mobile front end or a web application. So if you take the healthcare use case, you will have your sensors, your actuators, a gateway that will be wired, wireless, providing you the connectivity. Then you will have the cloud, allowing your devices to talk with each other and do some device management and stuff like that. And you will have the end user interface, a web browser, the touchpad application, etc., etc. So first part of the picture is actually the sensors and the actuators. Sensors are here to sense the environment, the actuators to act on it. That was kind of easy, right? So how would you do that with Java? How would you talk to your sensors? Well, if we take the Raspberry Pi use case, there are several technologies to do that. You can the Raspberry Pi is probably running Linux, right? You're probably running Raspbian. So it's totally fine to use the Linux sysfs API and manipulate the file system directly to access /sys/class/GPIO blah 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 and export your GPIOs, manipulate basically the pins and the sensors connected to your Raspberry Pi that way. The thing is that there are things that you will probably have a hard time to do, like monitoring in real time when an input is changing and stuff like that. So for that, there is a great technology that's called Pi4j, and that I'm actually using together with the other projects I'm going to talk about today. Pi4j basically is a Java binding to the wiring Pi C native library that does all the native GPIO stuff, including I2C and SPI, and you have all the Java APIs to manipulate basically your sensors. If you do Java ME embedded, then you have dedicated API, and you can develop your midlet that will allow you to do that. So I want to dive a bit deeper into Pi4j. So it's an open source project. You can download it from pi4j.com. Gives you, as I said, access to the wall, to basically to all the pins of your Raspberry Pi, or virtually any kind of platform, actually, because it's called Pi4j, but there's really nothing very specific to the Raspberry Pi. It's very mature, and it also includes support for popular Raspberry Pi shields. So who knows, for example, I think the most popular might be the Gert board. Who knows the Gert board? Yeah, so basically this is what the Raspberry Pi lacks, for example, is analog inputs. There's only digital. So thanks to the Gert board, you actually plug a shield on your Raspberry Pi that includes a dedicated ADC, a dedicated analog digital converter, and you have a way to control the ADC over a digital communication, and then that's fine, because you can start having temperature sensors and the like, analog temperature sensors and the like. So what happens in Pi4j, that if you happen to connect your Gert board, then you will have access to more APIs from your Java code, and you will start to be able to do analog readings and stuff like that. It also comes with lots of code samples, which means that basically you download it and you start running the I2C blah 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 sample, and you have pretty much all your everything you need already. Seeing it in action, well, it's actually a pretty convenient API. If you want to manipulate a GPIO you connected an LED to, then you will basically instantiate the GPIO port. So that would be the pin number 1 of my Raspberry Pi. I want initially the pin to be set to an high level, and then I can start putting the pin to a high or low level, or I have an API to directly toggle the pin if I have no idea what the state of the pin is, or if I don't want to bother reading the state. So that's a pretty cool open source technology, and you can obviously combine that with other Java libraries, just like the libraries and the frameworks you would run on the gateway, on the so in the case of a Raspberry Pi, it's likely that the Raspberry Pi will actually both be kind of behaving as the sensor, because you've attached sensors and actuators directly to the Raspberry Pi, and you want also the Raspberry Pi to be a gateway to the internet. You want to connect all the sensors to the internet, and you want also, and this is often something that people don't think about when they tinker with Raspberry Pi and with Arduinos and whatever. They don't think about managing the solution once it's in the field. Once you have deployed, even if it's just in your house, right? You've deployed a home automation solution. Ideally, you want to be able to upgrade the software remotely. You want to be able to install new software, to reboot your device if something goes wrong. So, of course, there's always, if we're talking Raspberry Pi, maybe you want just to SSH into the machine. But if we're talking about devices that are having connectivity that's not always on and stuff like that, you want still to be able to control the device. If the gateway only connects every 5 minutes or so, then you want the device to know that when it connects, there are some stuff that it needs to perform. It needs to download a new software package and stuff like that. So that's kind of the responsibility of the gateway, connecting the sensors and managing the hardware and the software at the edge of the network. So for connecting, well, there are two very popular protocols. You may remember Julien's presentation yesterday. COAP, long story short, it's kind of HTTP over UDP, really enables you to put your sensors inside the internet / web of things. The idea is that the sensor and or the gateway will actually expose a resource, as in a REST HTTP REST resource to the world, and that way it can be queried from the internet. With MQTT, it's more kind of a publish subscribe kind of model. The sensors, the gateway will actually push data to the cloud, to a broker, and will possibly receive data from the broker. Arguably, it gives you more room for local processing, because you will consolidate the data locally, and you will push big batches of consolidated data to the cloud every once in a while. So COAP, how would you use COAP in Java? There is an open source implementation of, I don't think actually there are other implementation than Eclipse Californium. It's an Eclipse open source project that's been, I mean, Californium has been an open source project for a while, and now it's part of the Eclipse ecosystem. It's very easy to use. Basically, the workflow is that you will extend the COAP resource class to define what is your temperature resource, what is your servo motor resource. So you will subclass the COAP resource class, instantiate a server, and start a server. That's as simple as it. That's as simple as that. So extending a COAP resource means that you will need to implement, if you want to, what it means for your resource, my resource, what it means to do a get, what it means to do a post, what it means to do a put, and what it means to observe the resource. So in my case, my resource knows how to deal and to answer to a get. So in case a get is issued, I will respond with a hello world string, and if there is a post, then I have all the liberty to parse what are the query arguments and stuff like that, to do something like create a new sub resource or something like that. So that's very simple to use Californium. You can even use it in an OSGi runtime, and we will talk about that actually later. So that's how we would use COAP, and if you would like to use rather use MQTT, then you have a Java implementation of MQTT in the Eclipse Paho project. So the idea with MQTT is that you will instantiate an MQTT client to talk to a server. I have actually quite a nasty typo here. It will work, the code sample will work, but we used to have to call the Eclipse initiative the Eclipse M2M initiative. Turns out it's now Eclipse IoT. So the right URL to use the MQTT broker, sandbox broker that we have at Eclipse would be iot.eclipse.org. So what I'm doing here is initiating a connection with the broker, and then there are two options. I want to either subscribe to the broker to say that in the case there is a message that is under a specific topic, then I want you to be notified, or maybe I want to publish messages. So that's the very short snippet of code for subscribing to a specific topic or topic hierarchy. I would need to set up a callback first. What is the callback I want to use? What is the callback I want to be called in case there is a message that's interesting to me? And then I connect to the broker and I subscribe to a specific topic hierarchy. And from that point, whenever any MQTT client in the world connected to this broker will publish a message under the topic, say my gateway / foo, then this client will get the callback called. So that's for connecting, and that's kind of like half of my presentation now comes everything about managing the gateway. managing when it comes to managing an IoT solution, you want to manage several things. Actually, you want to manage the gateway itself. Usually it embeds some kind of wireless modem. This is acting as a gateway, so you want to manage the routing rules, the firewall. So that's the kind of stuff you would need to be able to manage from remotely, basically, right? You want to manage the applications that are deployed in the gateway, because basically the gateway is acting as a container for all the applications, the home automation application, whatever application that you want to run on top of your gateway / Raspberry Pi / BeagleBone, whatever. You want to install these applications, you want to be able to install them, stop them, monitor them, have some kind of watchdogs, and you want kind of a framework, right, to take care of all that. You want also your application container to provide you with some nice APIs to manipulate the underlying hardware. You don't want to reinvent all the time the way to, you don't want to have to download RxTX for doing serial port communication and stuff like that. You want to have some common ground for starting to build and manage your Java IoT applications. So we have an open source project at Eclipse that is called Kura. Kura sits on top of the JVM and OSGi to provide you with basically a framework for building your IoT applications, as well as for managing the IoT gateway. So you have a nice GUI for configuring your gateway, for installing new software packages, and these software packages will actually have access to not only the Java and OSGi API, but also to Kura APIs for device to cloud communication, for access to the underlying hardware and stuff like that. So maybe just a few words about OSGi. Who knows OSGi, actually? Oh, that's actually half of the room. So OSGi is basically a dynamic model for building Java software. It's a standard. And it comes with a way to describe your Java modules, as well as to leverage lots of services that are built into the framework. Like if you want to do eventing between your software components, if you want to manage the configuration of the components, if you want to do things like UPnP, these are the kind of things that come with OSGi. Which means that it's actually pretty interesting to use such a modular approach for building IoT, because whenever you build an IoT solution, it's very likely that you will need to reuse some kind of library for talking Modbus or for talking CAN bus if you want to talk to your car, right? So you want to not only have a jar file that is actually the library, but ideally you want this module to be really a module, something that you can deploy within your application without falling into what's called the jar hell, right? You don't want to have conflicts in case you use different incompatible versions of libraries and stuff like that. So that's what OSGi basically takes care of. And there are several OSGi implementations out there. Several of them are actually open source. Kind of the reference implementation would be Eclipse Equinox. This is basically the implementation on top of which the Eclipse IDE is running. But there is also Eclipse Concierge, which is really targeting embedded device, and it really has a very, very small footprint and is meant to be embedded in devices. So basically, Kura, you can run it on top of Equinox or on top of Concierge if you really care about making your environment as small as possible. So what is Kura? As I said, it provides a nice web UI for basically you go to eclipse.org/Kura, you download a DBN package for the Raspberry Pi, you install the package on the Raspberry Pi, reboot the Raspberry Pi, and then what you have access. Your Raspberry Pi is basically from that point managed through Kura, or at least manageable through Kura. You can open a web browser, log in with the credentials, either default credentials or whatever you put to protect your Raspberry Pi gateway, and you can start doing things like monitoring the status of the device. You want to know the uptime. Well, you could, as I said, you could absolutely SSH into the Raspberry Pi, but depending on the network topology, that might not always work. So you want to have some kind of way to monitor the state of the device. We're talking OSGi, so you have bundles, software bundles deployed in the gateway. You can know whether they are running correctly or not. They have unresolved dependencies and stuff like that. You want to manage the network. You are building a gateway, right? You are possibly bridging not only sensors to the cloud, but maybe behind the Raspberry Pi are other devices, other IP devices that you need to somehow route to the internet, or the other way around. You want to filter them. So that's what you can do with the network management capabilities, firewall management. You actually deployed an application within Kura that does COAP. By default, this application won't be able to communicate with the outside world because you will need to open a rule and a port in the firewall. You want to manage the software packages deployed inside your Kura gateway out of the box. You install the Debian package for Kura, and you have just the basic set of Kura APIs and the basic web UI. But then you want to start deploying your home automation solution. You want to deploy this and that. So you have a dedicated UI for that, as well as API and APIs for doing application management. And we'll talk about that in a minute. You want to manage the settings of your gateway. You're actually tweaking the firewall, and for some reason you broke something. Well, you can roll back to a previous snapshot, right? That's something Kura also takes care of. And then in this area of the UI are the settings exposed by all the services that are deployed in the Kura gateway. As I said, OSGi and Kura, of course, allow you to manage the configuration of your software components. And the great thing with Kura is that these software components can actually also expose a UI for changing and setting the configuration parameters. So here, for example, in Kura, there is a clock service that talks to an NGP server to set the date and time. Well, automatically it's accessible in the UI, and you can change the settings of the clock service component via the UI. So how would you, that's basically the UI for managing the gateway. But then at some point you want to deploy your own application. If you have really sharp eyes, you've seen that this is actually a greenhouse application. I want to deploy an application where this is gonna go bad. I want to deploy. I actually built a software solution for managing a greenhouse at home. I want to connect temperature, humidity sensors to my Raspberry Pi, and deploy the application in Kura. So how does the typical Kura component look like? How would you develop a Kura application? Well, basically what you will be able to do is leverage lots of built-in services inside Kura. For example, the first thing you're probably going to be interested in is talking to your hardware to read data from a serial port or from the GPIOs. And so Kura comes with services that you can easily import and require in your own software component to deal with Modbus or to deal with CAN bus. Or if there's none, well, maybe you will develop your own service for doing for talking to the Philips SmartHome, for example, and then the service might be reused by someone else, right? So that's services for accessing the hardware. Then you get data from your sensor, and you want to communicate with the server. You want to make your data available. Well, you could use Paho directly, MQTT directly. We've seen the snippet earlier. It's pretty straightforward. But the thing is, the gateway might not always be on, might not always be connected. The connection might be flaky and wireless, 2G kind of wireless connectivity. So you have several transport layers in Kura, depending on the communication you would like to, the communication scenario you would like to use. You can use the transport service, which is basically pretty much similar to the Paho API. You can publish data. If this goes wrong, it's very inconvenient for you to manage the errors. That's actually not the point. You want to have a very straightforward API. But if you want the framework to take care of having some kind of offline local storage in case the connectivity isn't there, you can leverage the data service, which is, by the way, configurable from the UI. You, as a software developer, developing your greenhouse monitoring solution, you don't really care about, or you don't really know yet what server you're going to talk to. You just want to call the freaking data service to say, hey, Mr. Data Service, I want to push this data, make it available to the cloud. And then later on in the web UI, you will configure what is actually the actual server you want the data service to be bound to. And then on top of the data service, there is the cloud service, which is bringing even more features in terms of optimizing the bandwidth, making binary packets using Google protocol buffer and that kind of stuff. Once you have basically developed your software component using CAN bus plus the data service, for example, you will probably want to expose some kind of settings to the outside world, so you can implement a configurable component and describe all the metadata of the settings in your software component, so as it shows up in the UI, and people will be able to configure your greenhouse application or whatever you're developing. And last but not least, you will package your software component using, this is actually based on standards. So that's actually pretty interesting. You're using an OSGi standard for crafting basically a zip file containing a description of all the bundles that are in the zip file. And you can either use the Kura web UI to upload the zip file and ask Kura to install and start the application, or you can also do that over the air. You can put the zip file somewhere on Dropbox or on an HTTP server somewhere, and push a notification over MQTT to Kura to ask Kura to download the package and install the package and report any errors that there may be in the process. So I know this is kind of a lot of information, but you can read more on Kura. As I said, eclipse.org/Kura. You can download the Debian package, install it on your Raspberry Pi, and you have a getting started on Kura's wiki. So that was really like at the gateway level. The cloud, as I said, it's kind of depending on the architecture. You might not even have a cloud at all, but if you do, it's probably to allow kind of point-to-point communication. You want to use, for example, MQTT to leverage publish subscribe to allow sensors to see and talk to each other, or you want to do device management kind of stuff. So we have an Eclipse project that is actually coming to Eclipse. It's called Moquette. It supports basically all the features of MQTT, including the latest specification. It's very OSGi friendly. It even has WebSocket support. Very scalable. Leverages the LMAX disruptor. And very simple to install. There is a ready-to-use distribution. You download that. At the moment, as I said, it's not at Eclipse yet, but it's very, very easy to install and deploy. And that's open source as well. There are obviously other brokers like Mosquito, implemented in C. Ponte also acts as an MQTT broker. It's in Node.js. You have many options here. And when it comes to actually making the sensors data visible to the end user, well, you may want to build mobile applications, web applications, wearables, whatever. So so we are trying to stick to Java here, but obviously there are open source implementations of MQTT for iOS, for example. But if you really want to leverage your Java skills, you will probably develop at some point an Android mobile app. So there is, as part of Eclipse Paho, an Android service that you can use, that several applications can actually reuse inside your Android system. If you're interested in Android Wear, the mechanism that allows to do push notifications from the wearable device to the phone back and forth is actually pretty similar to MQTT. So it's very easy to have a companion application on the mobile phone that will take the push notifications that goes back and forth with your watch, for example, and turn that into MQTT messages. And if you're more kind of a web developer, you have a WebSocket client. You can use Ponte to bridge MQTT or COAP to the HTTP world. So yeah, you're not short of open source technologies, right? So in terms of tooling, well, the Eclipse IDE is actually pretty good at allowing you to do Java development, and especially if you're really interested in leveraging the OSGi way of life, I would say. Well, you have lots of plugins in Eclipse to do that, the PDE, MToolkit, and stuff. So lots of other technologies for doing Java at Eclipse. Home automation, SCADA, industrial kind of stuff, OM2M, BERT for doing data reporting and stuff like that. And since I'm running out of time, I just quickly wanted to tell you that we are running the EclipseCon Europe at the end of October near Stuttgart in Ludwigsburg, and this is gonna be packed with IoT content. We will have an IoT end conference on the day before the conference on the 27th. So you might want to plan on attending. We will also run a series of webinars and online hangouts, basically meetups on starting next week on September the 9th. If you want to kind of stay in touch with what is happening at Eclipse, join us. And that's it. I'm 1 minute behind, so if you have questions, I guess you will just come and ask me afterwards. Thank you.